Yes, I'm going to be talking to you today about climate change and ecosystem services, focusing on tools and methods for assessing impacts. An overview of my presentation, I first want to talk about why ecosystem services are important. Then, throughout my presentation, talk about why we should be moving towards a more integrated framework for ecosystem service climate change impact assessment. And also, throughout my presentation, giving some examples of tools and methods for assessing climate change impacts to ecosystem services. I thought Bob Watson did a great job of introducing ecosystem services today and talking about how important they are in terms of climate change. So I'm not going to talk too much about them, just to mention that there are many different types of ecosystem services, which makes it complex to analyze impacts to them as a whole. There are provisioning services that Bob talked about, regulating services, supporting services, cultural services, and under each of those, a whole bunch of different types. Ecosystem services provide great economic value to people. From the economics of ecosystems and biodiversity, TEEB, which was mentioned earlier on today a few times, the report pointed out or quantified that coral reefs provide on average $116,000 per hectare of ecosystem services to local communities. Tropical forests, $6,120 per hectare. A lot of money really per hectare for these places. And the poor are some of the people who depend the most on ecosystem services. They're also people that tend to be have the most difficulty adapting to climate change because they just don't have the resources to be able to do it. And you can see in the bar charts down here that anywhere from about 50% to almost 90% of the GDP of the poor depends directly on ecosystem services. So impacts to them are very important. To talk about moving towards an integrated framework for climate change impact assessment first, I see this as having three components that we need to think about here. First, there are the climate scientists that run the climate models, downscale climate data, and that's really what we have to work with to start off with our climate impact assessments. That information is then fed into some sort of climate change analysis that impact scientists tend to work on. And really that's a lot of, I think, what we're talking about here. But I think what's important for this group here, sitting in the middle between the climate scientists and then ultimately the decision makers, is how do you put this all together to be able to provide the climate impact change analysis and information to decision makers working on the ground in terms of visualization, the actual data and applications for being able to make decisions. So I've worked on a tool called Climate Wizard, as was mentioned, and we've tried to do this, taking downscale climate data and providing it to practitioners anybody who can access the web. You can download climate data from here. I also want to point out that we've tried to incorporate uncertainty analysis into this by providing ensembles of 16 different climate models, and you can look at the different quantiles of those climate models, what they project as far as the higher end and the lower end. Again, Bob Watson mentioned that earlier today, and I'll come back to that here in a bit. This is not an ecosystem service analysis, but the data from this can be used for that. And I want to give you an example here from the Mongolian grasslands, where the Mongolian herders depend directly on grassland productivity for their livelihoods. They are nomadic herders that follow where grass production occurs. If their livestock don't get enough forage from the summer months, then they won't be able to survive the harsh winters. And with climate change in the northern areas, projections are for there to be more harsh winters in terms of more snowstorms, and that is what directly kills livestock often are the snowstorms. So we wanted to quantify how might grassland productivity change in these ecosystems. It's not just the amount of precipitation that affects grassland productivity, it's the amount of moisture that's available there, and as temperature increases, evaporation and evapotranspiration increases, called potential evapotranspiration. This can be quantified using simple or more complex models. We used a fairly simple model developed by Hammond based on the Thornthwaite equation. And this can be thought of as the moisture demand in the system. So we then calculated the Aridity Index, which others have done also. It's just essentially the ratio between the supply of moisture coming in from precipitation ratio to the demand of moisture from potential evapotranspiration. And this was all data that came out of the Climate Wizard tool. And I'll mention too that we will be incorporating this potential evapotranspiration and Aridity Index directly into the Climate Wizard tool so that people such as yourselves or others can download it for use in their analyses. We then related the Aridity Index on the x-axis to the net primary productivity measured from MODIS satellite imagery on the y-axis there and found a highly significant relationship there. Then using the data from the Climate Wizard of historical versus future conditions under 3 different emission scenarios, quantified the % change in primary productivity in the grassland ecosystems. Here an example of one of them. This is the A1B greenhouse gas emission scenario, the more middle of the road emission scenario for 2080 that we use. And you can see that some areas, especially in the southwest of the study area, are projected to decrease by 15% or more in primary productivity. As the colors go towards blue, less decrease in primary productivity, and the blue areas actually increase a little bit there. We then overlaid the herder camp densities on top of this, and you can see that again, that southwestern corner of the study area here, this is the eastern Mongolian steppe that I'm showing you, is where there's the highest density of herders as well as the highest projected decrease in primary productivity. Now want to move on. Actually, first want to say that we then looked at this in terms of 3 different emission scenarios, and so depending on emissions reductions in the future, we may be under one or another of these. So this could range then from say decrease of 1.6 on average over the whole study area to a decrease of about 7% over the entire study area there. As I mentioned, we have 16 different climate models that we have used from the Climate Wizard. Those all went into this to create a median analysis, but any quantile, like Bob Watson showed earlier, from the lowest to the highest could be looked at under any of these emission scenarios. Now I want to move on to another set of tools, the INVEST tool set from the Natural Capital Project. INVEST stands for Integrated Valuation of Ecosystem Services and Trade-offs. It's a tool set that can be downloaded off the internet from the websites provided here. There's a book that was just published that you can look at there with some examples of how they've used this tool. It doesn't have climate change integrated into it, but by putting it together with the Climate Wizard data, I'll give you an example of how we assess climate change impacts to ecosystem services here. They take a multi-service approach. They have many different parts of the tool set. Hydropower production is one, avoid reservoir sedimentation, water purification, carbon sequestration, managed timber production, crop pollination, biodiversity are all different modules in this toolkit here. I'm going to show you part of the hydropower production toolkit to look at changes in stream flow in watershed in Mexico. First, I just want to mention that they take a tiered approach, and so I'm going to be showing you a tier 1 model, which is a model that requires less data to be input into it, so it's closer to the reality of data that we have at our disposal right now, or in general in different parts of the world. But they're planning on having tier 2 and tier 3 models that are going to be more complex there. And I think it's a good thing to keep in mind as we think about a framework for impact analysis. Here's an example of some results of integrating the Climate Wizard data with the INVEST water production tool. This is kind of, again, like what Bob Watson showed earlier from the UK, where in the middle here we've got the median of the 16 models that was run under the 3 different emission scenarios, going from lowest emissions on the left to highest emissions on the right. We can then, on the top, look at what's the more extreme case that the models projected for decreases in stream flow, and on the bottom are what's the less extreme case for decreases in stream flow, and look at the range there. I don't think the numbers matter as much as that the framework for doing this. So I've talked about a couple different ecosystem service modeling tools here. There's many others. I think I've just scratched the surface on really what you can do here. Hydrologic sedimentation, river flooding, grassland forest productivity, nutrient cycling, carbon sequestration, coral reef, the marine system, sea level rise, and coastal erosion. Just mention a couple down here. Coral reefs, there's reef resilience toolkit that I might recommend going to see. Looking at the sea level rise, there's the coastal resilience toolkit. That's reefresilience.org and coastalresilience.org. There are just other resources out there that I would encourage you to look at if you're interested in the marine system, since I haven't talked about it. Coming back to the integrated framework for climate change impact assessment, as I mentioned, the Climate Wizard takes downscaled climate data, provides it to users through an interface, visualization. You can download data from it in applications. It doesn't really have the ecosystem service integrated into it right now, but I think this framework can, by running the climate change information through different types of impact models, which then need to be provided back out to users. And rather than having multiple different models in different places and different downscale data, I'd like to see this all come together to be more efficient and effective in what we do and how we provide this information to end users, decision makers. In conclusion, ecosystem services will be impacted by climate change, and there are tools and methods out there to assess the impact of climate change on ecosystem services. I've shown you some, but I really think there's a need for us to move towards a more integrated approach that takes the climate data, integrates it into impact analyses, and ultimately provides it to decision makers working on the ground. Thank you.